example. So this is 6-1 part 2, but we're going to have another example of solving triangles. And so really nothing new with this one. I just thought it would be good to try one more together since they were kind of tricky. Solve each triangle, or we could say the triangle. So we're only going to do one. And round to 2 decimal places, just like usual. So remember, we're doing the law of sines in this section. You've got the side over the sine of the angle. That's kind of how it works. Side over sine of the angle. And you can do that for A, B, and C. And this is what we have for example 1. Big C, so that is an angle. Angle C is 36 degrees. Little c, so that is side C, is 8. And little b is 5. Now, like I did a couple days ago, I like to put all of this back onto the triangle, and I'm sketching mine just like I did on Monday. There's angle A down at the bottom left, angle B at the bottom right, angle C is way up there at the top. We know that is 36 degrees. Then side C is across from angle C. They told us that is 8. And they also told us that side B, which is across from angle B, is 5. Now, probably one of the hardest parts is just getting started. How do I know what to find first? I always try to take the easy route first. If I know 2 angles, I could add them up and subtract them from 180 to find the third. But I only know 1 angle here, so it doesn't look like I'm going to be able to do that just yet. So now I'm starting to think about my law of sines. And you always want to pay attention to what variable you know the most about. So A, B, or C, which variable do we know the most about? C, you know angle C and side C. And you also know a little bit about B. And I'm thinking if I took my law of sines, paired up the B's and the C's, the only unknown that I would have would be angle B. So that's what I'm going to try to find first. I'm pairing up the B's and the C's. So here it is. 5 over sine of B, because I still don't know what that is. That's what we're trying to find. Equals 8 over sine of 36 degrees. Now we cross multiply. Have to do that on basically all of them at some point. I'll be left with 8 sine of B equals 5 sine of 36 degrees. And there's still a couple more steps here, but first thing would be to divide by 8. And I want to go ahead and put this on my calculator. I'm typing in, make sure I'm in degree mode. Yes, I am. 5 sine of 36. I like to hit enter after that. I'm a scaredy cat. Don't like to do too much at once. Then divide that by 8. And this is not my final answer yet, so I'm not rounding. But I've got like a 0.3673 ... still on my calculator. Alrighty, now we have to inverse sine that number to get B by itself. Now, I showed you this the other day. If you have, this should be inverse sine of 0.3673 ... If you have that A and S button, go ahead and use that. If you don't, then try to just type in as many places as you can. Again, you don't want to round until the very end of the problem. So it should be about 21.55 degrees. Yes. Yeah, I'm looking up there, but that's not on you. Yes, that would be fine. Sure, that works. Okie doke. Now I know angle B, so what would be the next easiest thing to find? Yeah, I'm kind of thinking angle A would be easy to find next. If you take 36 plus 21.55 degrees, that is like a 57.55 degrees. Then I can subtract that from 180 and I get 122.45 degrees. Angle A, angle B. I still need to find little a, and because these are not right triangles, you can't use the Pythagorean theorem. You're pretty well stuck with the law of sines anytime you have to find a side. Angles can sometimes be done differently, but with the side, you're looking at the law of sines. Now definitely use the A part of the law of sines, because that's what you're trying to find. And you compare the A's up with the B's or the C's, because at this point you know everything else. I just chose the A's and the B's. So it's A over sine of 122.45 degrees equals 5 over sine of 21.55 degrees. And here we go again, cross multiply. I'll end up taking 5 sine of 122.45, I like to hit enter after that, divided by sine of 21.55, and it should be approximately 11.49. They didn't give us units, so we can leave those off. Any questions about the first one? Again, that's just like what we were doing on part 1. So a little bit of review right there. Now, there's one more thing that we're going to do with oblique triangles, and that is to find the area of an oblique triangle. We're not just trying to solve, we're trying to find the area. Now, this is kind of like the law of sines in a way. There was like 3 parts to the law of sines. Well, there's like 3 parts to the area formula for an oblique triangle. Now, it's not going to be like the law of sines where you have to pair up 2 of them and set up a proportion. This is pretty well just 1. All you have to pick off of this list is one of those formulas. No matter which formula you pick, you should get the same answer. So it says area equals 1/2 little b, little c, sine of big A. That's going to give you the same answer as this, 1/2 little a, little b, sine of big C. Or you could use 1/2 little a, little c, sine of big B. 3 options. Either or any of those would give you back the correct answer. What you want to pay attention to, though, is what they give you in the problem. If they give you little b, little c, and big A, you should use that formula. Or if they give you little a, little c, big B, use that formula. At no point do you have to use more than one. You're just picking the best fit. Okie doke. And I think there's just a couple of these. So like I said, kind of a short lesson here for part 2. But main goal is to find the area. And just like we have been doing, we're going to round to 2 decimal places. Find the area, round to 2 decimal places. Okie doke. And I'll give you this one as a list. Example 2, little a is 10, little c is 12.4, and big B is 36 degrees. I don't have to solve the triangle. I don't have to find everything else. I just have to find the area. Now, you've got the formulas in front of you. I'm just going to put them back up here so we can look at them together. I want the formula that fits what they have given me. I know little a, little c, big B. So, little a, little c, big B, that is the part of the formula that I want to use on this problem. Now, they're not all going to be this easy, but it turns out with example 2 that once you find which formula you want, it's really just a matter of typing stuff into your calculator. I plugged in 10 for A, 12.4 for C, and 36 degrees for B. If it helps on your calculator, instead of doing 1/2 as a fraction, just type in 0.5. It's a little bit easier to do. So 0.5 times 10 times 12.4 times sine of 36. It's as easy as that, just typing it in. It gives you 36.44. Now, I know used to when they didn't give us units, we just kind of left the label off. Now that we're talking about area, we really should square our label to make it legit. This is an area type of problem here. So go ahead and do just units squared. That way it definitely is area. It's not just a length. Okie doke. Questions about example 2? It's a pretty nice one. Well, we're still doing area right here with number 3, but we're going to run into a little bit of a problem. We've got angle B equaling 64 degrees 15 minutes. Little a is 8. And angle A is 42 degrees, 30 minutes. Now, I don't even know what formula I'm going to pick yet. Right off the bat, I don't like the minutes up there. I'm going to turn the minutes back into degrees. So, you told me this the other day. I got to divide by 60. I'm typing in 15 divided by 60, and it's 0.25. So let's think of angle B as 64.25 degrees. I'll come over here and do the same thing to angle A. So 30 divided by 60, that is just 0.5. So we're going to think of angle A as 42.5 degrees. Okay, I feel better about that. Now, I'm looking at my area formulas, and I want to pick the one that fits what they have given me. If I picked this formula, I would only know big A. There's only one part of that formula that they've given me, so that doesn't sound too good. If I use this one, I would only know little a, and that's again kind of a bummer. So I'm moving down to the last one, and of all three of our options, this is probably our best option. We don't know everything about this formula, but we know more about this one than we know about those. So I'm going to go ahead and decide to use that last formula, 1/2 AC sine of big B. Now, the obvious problem is we don't know what little c is. That's side C. We don't know side C. So let's go back to the law of sines, and hopefully using the law of sines, we can figure out what little c is, and then we'll have something to actually plug into that formula. Okie doke. So here's what I'm thinking. Law of sines. Here's the law of sines. I know I have to use the c's because I'm trying to find c. And which other one should I pair it up with? I'm kind of thinking a's because you know everything about the a's. But does anybody see yet another problem with this? Yeah, you want to find little c, so that needs to be a variable, but you don't know big C. So next step over here, before I can use my law of sines, and before I can use that formula, I need to figure out what big C is. So how could we do that? Finding big C. Yeah, you know A and B, so add those up. You should get 106.75. Subtract that from 180, and that tells me that angle C is 73.25 degrees. Okie doke. Now I'm going to go for the law of sines. So here we go. Little a, which is 8, over sine of big A, which is 42.5 degrees, equals little c, which we don't know, over sine of big C, which we just found to be 73.25 degrees. Now, cross multiply, and we have to divide by sine of 42.5 to figure this out. And here I go, 8 sine of 73.25, enter, divided by sine of 42.5, and that is approximately 11.34. I'm going to go ahead and round that number. I'm not done yet, though. Remember, we were supposed to find the area. We haven't done that yet. We found little c, which we can use in our formula now. So last step, finally, we're going to take 1/2 times 8 times 11.34 times sine of b, which was 64.25, and we can round this again. That should give us 64.25. To the nearest hundredth, it would be like 40.86. Again, to tell that it's area, we should put units squared. It's not just a length question.
So I did mine just a little bit differently. Instead of using the third formula, I used the one in the middle.
Yep.
And I pretty much got the same answer, but instead of 0.86, I got 0.87.
That is fine. Yep. So you found angle C by adding those up and subtracting, and you probably found little b by doing the law of sine stuff. Yep, that is perfectly fine. Good deal. Anybody else? All right. Well, I think most of the area problems in your homework are the nice ones where you can just basically plug in what you have and you're good to go. So this is T47 from page 410. The first problem up here, number 14, is the one that you're supposed to solve. So whatever they don't give you, find that, just like we were doing on part 1. And then 35 to 40 are the ones where you find the area.